should be recording now. So
Emphasis on the word should.
yeah,
All right. How's the sound level?
sound is okay.
All right.
But to get forward, I think it's now time that I will introduce Tuomas Rinta. He's
Hello.
the development director working here in the company, and he will be hosting us tonight. And Tuomas will tell more about the agenda and the practicalities and such. And I think I'm personally at least very excited to hear what Tuomas has to bring us today. So let's give a good applause to Tuomas and welcome him to the stage.
All right. Thank you, everybody, and I hope he shares his excitement after I finish speaking, but that remains to be seen. So, as said, my name is Tuomas. I work here at Unity Technologies Finland as development director. But before we go any further, a few practical matters. So, I'm going to talk for some time. I think we have 1.5 hours for that. I may use a bit more. Well, we're going to take a break roughly in the middle, but during any of that time, realizing you've had one beer too many and nature calls, the bathrooms are on that hallway on the right side. Looking from this, there's 2 bathrooms that have WC on them. There's the one closest to the elevator has one reserved for the ladies, otherwise it's unisex. If you feel the need to drink more because I bore you so much, there is alcohol. I will not mind if you go get it, unless you do it constantly. Then I will judge you for your alcohol abuse. But we're Finns, that would require quite a bit. Okay, I don't count you. I will judge you immediately because I know you. So, about the talk, there's a bunch of slides I will be talking about things. If there's anything you want to ask, challenge, say you disagree, say agree, do it right away. I'm more than happy. I want this to be, yes, you disagree with me already, you have your hand up. I want this to be more of a discussion rather than me speaking. We have a few people in the audience from Unity. Can you raise your hands? 1, 2, 3, plus a bunch of people in the back. So these people are here for one reason, for multiple reasons. One of them being that I sometimes don't say the proper things, and they will blurt out things like, it's not like that, when I say the wrong things, and they will correct me. And they are also, sometimes on some of the things I will speak, they are the subject matter experts, and will be filling in my stupid answers to your excellent questions. So I'm looking forward to having a dialogue, not just me doing a 1.5 hour monologue, because nobody wants to see that. But I guess, without further ado, do we have to? Yeah. I think there are some chairs over here if you need a place to sit.
Yeah. Tuomas, one
Yes.
practical question.
Yes.
Will we get like slides afterwards?
Yes, I can provide them. You will need to actively remind this, because last time I did a presentation like this, promised to provide slides, I never did. So when I fail to do that, please remind me. So, what I want to talk to you about today is not really going into details about you should do this, you should do that. Rather, going over how we see Node, how we've used Node, what's our story been like, because we've been using it for 5 years. And that's quite a long time in technology. That's even a longer time for a technology that like Node.js. And as in the agenda, we had split it up into 3 different groups. I'm going to talk about the past, on where did we start from, why are we using Node.js, how did we get started, how painful was it in the beginning, and how did we go through scaling up a product, getting more and more volume and more features, and what kind of challenges we saw there. And coming up to the point that where are we right now? How do we run things what's our infrastructure like, what have we learned during the 5 years, and then finishing up into, if we were to do it again, would we use Node.js? Should we do differently? And these are not really clearly different sessions, even though they have headings. So I'm going to take a break in the middle when it feels right. So, but again, at any point, if you think that the question is more forward-looking or it might be answered by my later slides, raise your hand, raise out things, and let's start a discussion. But let's start from the beginning. We were not always here in Helsinki a company called Unity Technologies Finland. We were a company called Applifier. Have any of you heard of Applifier? Wow, we're famous. We were not that many people in the beginning. When I started in 2010, we were 8 people, or actually I was the 8th person. And what we did is we had this thing on Facebook. So Applifier was founded by a gaming company called Everyplay, which made games on Facebook. And like a lot of game developers, one of the big challenges they had was how to get users for your games. And what they did is, this was prior to my time, that's why I say they created this cross-promotion program, very standard old web click exchange. Somebody clicks on the banner in your game, gets sent to another game, you get 1 credit which you get exchanged back to another user. And it got really big. So big that actually making games no longer was a good idea, rather focusing on this marketing thing. So the games went away, partly because they were actually not financially successful. They were great games, but if you don't make money, it's hard to pay the salaries. Now, however, this thing, I mean, sliced bread. Best thing ever. And as said, as you can see in this old marketing slide dating back to late 2010, we reach 150 million users monthly across the world on Facebook. That was a lot of users to us back then. And given that this was the technology stack we started out with, there were some minor challenges. So, I mean, given that the company started out making social games, of course, games come with, especially online presence games, come with scalability challenges. But since the guys, Jussi Lakonen and there are others, thought that, hey, this game is what we're going to do. We're going to just spin off this little thing and run it on top of the game to make the game successful. The cross-promotion was just to make the game successful. So nobody really spent time in running the cross-promotion system. It was basically just some scripts gotten off somewhere for a few $100, then custom code, just to get it up and running. And then things happened. Some of you might have heard the phrase hockey stick curve, which makes the traffic goes like this. And this doesn't go like this. It goes like this when that happens. So the first thing was to swap out MySQL for MongoDB. And remember, this is summer 2010, so MongoDB is like hot off the shelf. Well, it ran. Yeah, there was some work to be done, but it ran. Then the database is no longer the bottleneck. Now the front-end code is the bottleneck. So one of the developers come in saying, hey, you know, we kind of know JavaScript. There's this technology called Node.js. We should use that. And the guys go like, yeah, we should use that. Which one of us know JavaScript? And the guy's like, I know jQuery. It's like, dude, that's not JavaScript. I'm like, okay, we're going to write it. Over the next couple of weeks, the guys go through the code, port everything that pertains to add delivery from PHP to Node.js. In about 3-4 weeks' time, we upgraded from PHP to Node.js with 0 downtime. We're like, oh shit, we're good at this. And it was not a small feat. 2010, running on Node.js 0.4, we served 700 million ads per day. We posted this on Twitter, And Joyent, the company who at that point was the main company behind Node.js, came like, oh shit guys, you're the biggest Node deployment in the world. And we're like, well, we learned it 4 weeks ago. So it went pretty well, I would say. I'd say I'm pretty proud. I unfortunately cannot take credit for it myself. I had been at the company for 5 weeks at that point. I was like, good job guys, you did well. Here's some beer. But there, we embarked on our 5-year journey with Node.js, and still going strong. But it is about exactly 5 years right about now, because I had been at the company about like 4 or 5 weeks when we ported over, and I got the 5-year mark at the company last week. So it's been a long time that we have been running it. So for us, it's like, can we switch to a new technology? This is too old. So, but it was a risk decision, of course. But we started doing it gradually. So, as of course, our product was composed of multiple things. We had an admin panel for our publishers who used the cross-promotion bar in their game. And then we had the ad delivery APIs. And we actually ported only the ad delivery APIs to the Node.js backend because what we still had was the admin, which actually wasn't getting that much traffic. Of course, we had a lot of game developers, but they were counted in the hundreds. So we're not going to have traffic with that. And given that we've just picked up this new technology, we're not going to build an admin UI with it. So we kept running on PHP and Symfony for that, because we thought, well, this is better. PHP is a great tool, and Symfony is a great framework. Well, we were young and naive. But it was what we had. In the 5 years, one of the key things was that we didn't want to really port over existing technology unless it was absolutely necessary, because if it works, don't fix it. Works very well if you have very limited resources, which we did. Because since we were about 8 guys and we were running an ad network with 700 million ads served per day, a lot of our time went into figuring out, why does it not scale right here? Why is it crashing? And our auto-scaling system at that point was like, well, the weekends are a peak. Should we add 3 more servers for the weekend so it keeps running? So I remember that time we had a Node server setup where we had 8 processor systems on AWS, where we ran 7 instance Node processes on the server, leaving one of them for the Mongo client, MongoS process. And we actually had to do that because every now and then MongoS would start eating so much CPU, it would start crashing if we didn't leave it enough CPU. And luckily those days are past, because I don't think everything went very smoothly, and there was a lot of hands-on stuff that we had to do. So, well, we survived. In hindsight, it was somewhat of a miracle, but I kind of keep explaining that we're just so good that we created future-proof code that kept it running even though we scaled, which was a blatant lie. We got lucky.
Question, like, until was the limit that the PHP could like handle all the heads that was like of course 700 million, you told me, yeah, it was starting to crash and was quite impossible.
Yeah.
But until when you decide, like, yes, PHP is being a bottleneck and now it's trying really to change?
I think we were losing something like 15% of our queries. So that was kind of like, because if I remember correctly, we were like not serving a large portion of the API ad requests that we were getting in. And I was like, this is not good. And this was a point where we realized that we've optimized PHP to the maximum, and we can of course add more servers, but at that point still we were a very small startup, and we were not looking for a very large AWS bill at that point. It was really making most of what we could with the available instances that we could run on AWS. I mean, later in 2011 we did close a 7-figure investment round with multiple people, which allowed us to scale up easier and get more servers, get more people. At that point we didn't have that. So it was, since front-end servers which do not themselves do any data processing like storing, You can of course scale very easily by just adding more instances if you have the money. So when we started actually losing traffic and publishers started complaining that I'm actually seeing a gap here, then we knew that we must get it run pretty quickly. However, luckily we were at that point already in the progress of porting over to Node.
Would you tell you were quite lucky because those was just fresh, and nobody knew in that time what was the capacity of really Node.js? Or?
Yes, we were lucky. We made the right choice. The choices were a lot more limited in late 2010. So it was PHP, Java, Ruby, Node, Erlang, which nobody fucking knows. Except for like 3 people, and they used to work for Ericsson. But it was different. Then of course there would have been writing it in C. Then the maintainability is always questionable. Well, let's put it. It is maintainable. It's really slow to maintain, and it's even slower to add new features. So we did get lucky. It could have backfired us. Now nobody knew if the project even had a future. I mean, no. It could have been that 0.4 was the last version. Maintainers decided that, well, it's not really taking off, we're going to kill it. Then we would have been in trouble. So we got lucky, I admit that. And we spent a lot of time thinking about it, but it was a gut feeling that made the decision. Weighing the options, because one of the things that we've always liked about Node is it's fast to develop with. We got it up and running very quickly due to the language's nature. That's one of the biggest things that helped us make the decision thinking, hey, if we go with this, we can build it up very fast. Because if we had chosen Java or something like that, there would have been a lot more overhead in building the product. Plus, server costs would have been probably higher at that point, before we would have optimized. Node allowed us to do a very lightweight, lean solution to the problem. Alright, so, coming back. As said, we didn't want to port over anything that was not mandatory, so we focused on only moving over the API delivery, and only did Node.js for new products and features, because this was an easy way to transition. We kept old services running, started adding new ones, having them communicate. I think in a way you could say we were doing microservices before microservices were cool. Except they weren't that micro, but the idea was the same, to isolate these and create communication between. And of course the natural next step was to JavaScript all the things. I mean, kill out PHP and server-side rendering of any of the pages, and for new products, new admin panels, go with a full JavaScript stack. Because at that point we were heavy users of Node.js. We had a lot of servers running, we had a lot of people joining the company who, if they didn't know JavaScript, they were apt to pick it up very quickly. Because in 2010, late 2010 when I started, at 8 people, 6 months later we were 24. And 2010, late 2010, early 2011, you can imagine the ability to recruit people who know Node.js. There's like 3 of them, and 2 of them work for us. So basically we went out, how we still like to do recruiting, we recruit people who actually know how to build shit. And say, okay, we just happen to use a different technology than you. So pretty much everybody who started had a ramp-up time saying, okay, welcome to the company, next 2 weeks, you're going to be nose deep in Node.js, reading our code, figuring out what it does. We're going to help you through the hoops and some of the pitfalls we already know. But this is it. We're going to go all JavaScript, because at the backend we're running Node.js, as a database we're running MongoDB, which is basically a JSON document storage, which is kind of like JavaScript notation, so they fit in very well. So why not extend it to the front end and go with Backbone? So it was on paper, it's a beautiful setup. You have JavaScript all the way from the backend to from the storage to the front end. And the idea was that this is an easier way for us to transform people that have been either pure front-end developers doing things with Backbone, which was pretty new at the time, to transition them to do work with Node.js as well, or take Node.js developers saying, hey, you're now responsible for building the front-end implementation also with Backbone. Well, it doesn't work quite like that. Now, one of the things is that back-end developers often make good front-end developers, because there's the design things and those that you should actually know. And front-end developers don't always make good back-end developers, because things like optimized data structures and algorithms and performance don't always go hand in hand with front-end developers. Well, we got there. What turned out was, if you didn't know Backbone and never had done JavaScript-based front-end development, there turned out to be quite a learning curve. That was kind of surprising. But natural in hindsight, but we were like, yeah, it's JavaScript, you should be able to pick it up. No. So, it took us a while, but we started pushing everything to this model that whenever we do something, we have a template, you take the Backbone, put it there, we set up a Node.js project using Express, and you're good to go. And we got there pretty well. The stack is mostly the same. We've added Angular to the front end on some aspects, depending kind of on the project. And we've added a few more tech stacks, but I'll come to those a little later when talking about the present. But as you can imagine, first starting with 8 people doing 700 million ads a day on Facebook and transitioning then to what we did next was doing a actual video ad network on Facebook. Building video delivery, things like that, better targeting algorithms, then moving on to mobile. It was quite a ride. During the 3.5 years before we were acquired by Unity, we built a lot of products. Not all of them saw the light of day, but one of the things that was there that was Node.js allowed us to do them quickly. We prototyped quickly. We got things running. We did 8 weeks of product development, got something concrete, sold it, realized it doesn't sell, scrapped it, built the next product. Because we got really, really far with the Facebook cross-promotion, but the realization was that this is not going to fix everything. This is not going to be the end of the game here. We need to go deeper. So we built a lot of things, and the key of them was the ability to prototype quickly. Of course, it was not always a smooth ride, especially since we started out with a very, very bleeding-edge technology stack. And one of the surprises was that updating between node versions was horrible. This surprised us quite a bit. Going from 0.4 to 0.6 was not as easy as we expected it to be. We actually had projects for this. We had to take aside 2-3 weeks of development time to actually make this happen. Now, Node from 0.4 to 0.6, Node didn't actually change that much. There are a lot of new developers coming on to Node all the time and creating new packages, updating new packages. People who had written some original NPM packages were like, oh shit, I shouldn't have done it this way, because everybody knows that when you write software for the second time, it's better the second time. You learn from the first time. So they rewrote them for Node 0.6. So we tried it saying, okay, let's port over to Node 0.6, works, we need to update package. Nothing fucking works. We went in too early. There were so many breaking changes in the updates. So we actually talked about just today with our DevOps, and I think the turning point was 0.8.2. After that, things stabilized. So what we did, we ended up having different services running on different versions of Node. We had 0.4, we had 0.6, 0.8, and our DevOps wanted to start stabbing people. Because when things broke, they had to go in, it's like, oh shit, what is this supposed to be running? 0.6, oh no, it's crashing. 0.8, it doesn't even start. 0.4, yes, it runs. And this at 2 in the morning and at Saturday night when we suddenly have a peak. And New technology, I remember this one midsummer evening. It was a beautiful day, or beautiful evening. It was about 11 o'clock. I get an email from a client say, hey, we actually decided to go live with our game right now. You're going to be seeing a surge of traffic, and everything crashes. I call the DevOps guy. He's in the fucking tent in the middle of nowhere and starts debugging over GPRS. Kids, do not go with bleeding edge technology, because it will give you a whole lot of new problems. And we had advantages from Node. I mean, we got so much done which we couldn't have probably done without it. And I mean, we got past growth. We scaled up very quickly. We doubled our traffic every 6 months, hell, every 3 months. And we got there without dying from the AWS bill. But then we got to the situation that shit crashes. We go Googling for it, saying, hey, there's these issues. There's nothing. The internet does not know of an issue like this. We find one response, like in the legendary XKCD comic, and there's nothing there. I'm like, what the fuck is happening? I'm sorry, I also noticed I curse a lot. I hope nobody's offended, but I do that when I get passionate about something. Throw small things at me if I'm...
We actually have even better cases. We actually found out our own blog posts where we complain about these problems.
It's like, hey, there's this blog post. These guys have the same problem. Oh shit, it's ours. So we learned a lot of things in the hard way. And I said we were very early users of MongoDB, and being an ad network, we track users. We see 150 million of them, and of course that changes every month. They're not the same 150 million people. We track a lot of users. We track them in games. We track their behavior, which ads they clicked, which have they seen, because that's how ad networks work. So we eventually have to start sharding. Turns out MongoDB shards well on paper. Reality, not so well. So what happens is, I think we were in MongoDB 1.6 or something like that.
Things have changed.
So this was 2012, and when we learned things the hard way at that point. Again, bleeding edge. I mean, this was stuff like the knife's not in the skin yet, so it's not even bleeding. It's before that. So we start sharding. Then what happens is, like, every now and then MongoDB goes unresponsive for 5 minutes. Not a very good thing for an ad network. Then it just dies. And we're like, what the hell is going on? We start debugging this, and I think MongoDB support was like, yeah, you're doing it wrong. We're trying to figure out what's going on. They did help us out a bit and got there, and what turns out is that there's actually a bug in MongoDB sharding that causes it to go unresponsive, but it's not triggered until you have enough volume. And apparently the configuration we're doing, nobody else had hit it yet. So I think we submitted a patch even to MongoDB in this case, and which was then merged. This is the fun stuff using new technology. If it breaks, you get to fix it because no one else has. Stack Overflow will give you nothing.
A question.
Yes.
So like already mentioned, okay, like you know, like for like Node.js, you were like among the like highest volume like Node.js like using company. So I was thinking like, would it have been like any different if MongoDB, I mean like if like Node.js or like MongoDB had already been stable, because you probably would have been the first one using it with such a high volume.
I don't know. One of the things that there was not much of a community around this. As I said, we had to do a lot of our things ourselves. And that was one part of the problem. And of course, we hit a lot of snags that we knew that there were bugs. So the stability would have fixed us. We would probably now be still running 100% on MongoDB because it would shard well, because we have actually transitioned away from MongoDB mostly these days due to exactly these issues. So things might be different, but hard to say. I mean, we were running on fumes in some of the cases when it came to performance, but we got there, so it's really, really hard to say how things would have been different, but I don't think it would have made it harder, at least. So, I mean, but it was just easier to optimize the code. Again, with Node.js, it gave us the versatility to go after the code base a lot quicker. There was no refactoring was fast. So we changed things. Instead of trying to shard, we just changed how the system works. Also, we learned the hard way that handling memory leaks in Node.js is a pain. And turns out it's really, really easy to create them. Turns out number 2, Node.js has memory leaks. Still has memory leaks. So it's actually easier to kill your Node.js processes every X request and spawn a new one than to actually fix all the fucking memory leaks. To this day, we still do that. I think we didn't do it for a while and it was a problem. Yeah. So we have a system set up that will kill all the Node.js processes that have been running for X request and spawn them again.
Has the number of requests required in between the restarts increased at least?
It's currently set to maybe 50,000 requests, and basically the Node.js process tracks it with a global counter, and it adds some random number, so it will turn itself down every for 5 to 55 requests, 55,000 requests.
Yeah, so this was of course kind of a surprise to us, coming from, of course, PHP can have memory leaks, especially in C. Java, way harder, but here, surprisingly easy. So, hey, let's do these anonymous functions and leave some references there. Okay, that's fine, that leaks a bit of memory. How about we do that then 2 million times in a row? Yeah, a problem. So, a lot of these things really hit you at scale. It's like, yes, it works fine in my tests. What if we do it 27 million times? No, it doesn't work anymore.
Question, like you told you were like hitting 700 million like heads.
Yeah.
And even though you decided to go to MongoDB, I was thinking why you didn't decide to go like to big data, like Hadoop or something like that, to handle this kind of.
Hadoop didn't back end. Well, Hadoop had only the H-base, which would provide with real-time written performance, but it wasn't well enough suited for like this domain problem. Nowadays we use Cassandra to store the really big database which we have. I believe the biggest database in at least Finland, which serves something like 50,000 transactions per second, and it spans currently 60 machines in Amazon.
And and I think one of the problems with Hadoop is that it can get very expensive very quick.
Also, Hadoop didn't have really good setup for handling disaster recovery and losing several nodes at once back then.
Yeah. Hey, if you in the back are having a hard time hearing the answers, I can also repeat, because he's talking this way and you guys are over there. So, but just shout if you do that. But sorry.
Yeah.
Yeah. Yeah. But, so MongoDB was, and given that we were using Node.js, MongoDB and JavaScript, they go together rather well. Because JSON is the commonly used transport in JavaScript. MongoDB, well, it's a glorified JSON document storage. Simplifying very, very much, but
Yes.
yeah. And cost versus what we got at that point, MongoDB was the choice to go with. Because I mean, MySQL also scales. I mean, Facebook has proven, but then there's other issues with that. Plus, it requires a lot of maintaining to get MySQL to scale. So, but I think one of the things that we learned is that to avoid memory leaks, we need to be really, really careful. I mean, there honestly was no patent solution to fixing memory leaks in a language like that. It's just, if it crashes, it's leaking memory, most likely. Or if it crashes immediately, you have a bug. If it crashes after 10,000 requests, it's memory leak. Simple as that. Not so simple as that, but it was a problem. It was hard to pinpoint. Anonymous functions leaking memory and problem. So, coding conventions. How do you look for this? Understanding what causes them. Lights out.
Pannaanko käytävältä valokatkaisija, mikä on alimpana?
Yeah. All right, so everybody please take a hint. No, I'm sorry, I don't know why they do that, but no, it's 7 o'clock. I think they're set to go off then. All right. Then, of course, because Node was a new platform, and it was new to us, and building things around it wasn't really matured, we got kind of hit every now and then with external dependency, especially relying on NPM. And it was funny, like things crash, we need to restart servers, NPM is unavailable, we look at the wall and go, fuck. Because there wasn't much to do. Because all of this was new to us, and I mean, if you went Googling for Node deployment solutions at that point, you ended up on Joint's website, and that's about it. So we had to craft a lot of things ahead. And I said we didn't have auto-scaling at this point. Our auto-scaling was adding 4 more servers and hoping it would last over the weekend. And monitoring and people waking up at the odd hours of the day. And that should say deploys. Sorry for the typos. I think you got that. Now, of course, I promised to talk about the... past, but while on the subject of NPM, I'm going to go on a rant. Because... there are things that we've noticed that are issues. There are things we've noticed that are actual problems and that concern us around the NPM. And now, one of the best parts of Node.js is the community. It's a large, growing community. It's a very active community, as we can see here. I mean, there's a lot of people here, and there were even more on the waiting list. There's npmjs.org. It has a lot of packages. Oh, did I say best? I meant worst. Now, that's meant to be a provocative statement. And I'm not talking about the people here. I'm talking about how things work, how we've seen it, what kind of problems it arises. And there's a saying that goes around in this company that comes out of frustration, which says, Node is the new PHP. There's a lot of people writing Node who should never ever write services for the backend. And one of the problems is that it's based on a language that used to run in the browser. You could do stuff and it would work. If it took a few bit longer, that was fine. The user didn't notice. Now, do the same thing on the back end, we're not happy. And that's fine, that's on us, of course. But then, for us to use Node, we have to rely on the community. Because it makes no sense for us to try and create everything ourselves, but that makes using what the community has provided just harder. We need to be more prudent into what we use. And then there's, of course, this. Okay, this is probably people just know about, but it's a pet peeve of mine, so I rant about it. And NPM, just like any package manager, is actually a security issue. How many of you think about this ever? Good. How many of you are doing this in your package, Jason? Get out now.
I'm doing NPM shrink wrap. Yeah.
Good man. Because if you're doing this, please stop. Now the problem is that even if you're doing this, the packages you're relying on, the packages they rely on, you have no control over them. They might be doing this, and you don't want to go through all of them. And I mean, it's annoying. It is very much alive as a problem because for us especially, JavaScript as a language is prone to errors, the way it works. As I mentioned, small memory leaks here and there due to how people write anonymous functions and like that. It's fine if you wrote your package, you do a small change, accidentally you leak just this much memory. In your tests it just went through. And for us, it starts crashing everything. We pull our hair to figure things out. And then there's always the worst case scenario. So you have your application, you depend on A and B, A depends on A and 2, then A2 gets compromised, and you're fucked. So, as right there, please use npm shrink wrap. Which one of you are not using it? Good. This is something that I just wanted to bring up because it annoys me as a topic. But it annoys me maybe a bit more than it should because I'm paranoid. I think about the bad things that people could do to us. We're a very large scale ad network. We're a target, honestly. I mean, we do get iffy traffic every now and then, see people trying to scan our services to get information. So we need to be extra careful. So that annoys me. And when people say that they don't do that, that annoys me.
Do you like do a code review for each package version, line by line?
No.
I mean, that is exactly the problem because that's the only way to actually be sure.
Yeah. So to use shrink wrap properly, you should first do that. Now the problem is that in many cases that's just not possible. So there's multiple factors for mitigating that. One is to use packages of known sources. For example, somebody argued to me like, hey, you Apache could have these things. Well, I trust stuff from Apache a bit more than your random Canadian front-end developer who published stuff on npmjs.org. Now, of course, that doesn't mean what happened with Apache is HTTPD was actually tainted at one point and distributed a vulnerability put in there by malicious hackers. So that does happen. Now, here it could very well happen, and we can maybe trust others more than others. So what I urge developers to do, and we talk about this every now and then, is like use caution. And like if you're taking some code that's this much, are you really sure you want to use an npm package for that? Doesn't make sense. Using something like Express, yes, that actually makes sense. Slightly more known, but it is a problem. Maybe for us it's slightly more, it's a bigger problem due to the fact that we're seeing more errors come due to JavaScript. So it's not fun. But there are no perfect solutions. So there's the Node Security project, nodesecurity.io, which allows you to plug in a service to, for example, Jenkins CI, which would match your build against known vulnerabilities in packages. So that's, for example, a tool that you could use to scan things. But
Sorry, talking about frameworks, are you using Node.js as pure, or are you using on top of that any framework, well-known like Happy or Coho or Express? Or
Express is what we're using.
Okay.
Yes, and Express was, I think, was available already when we started. Does anybody remember?
We used to use Connect, which is basically
Yes,
so
that's
that Express is built on top.
yes.
Actually, Express is a library.
Yeah.
It's not a framework.
Yeah. So
How you know?
let's throw small objects. But yes, we have been corrected. So Express is not a framework; it's a library. But yeah, Express is the only thing we're using. For us, as performance is a very big thing, we do like to keep core functionality and things that get a lot of code execution to a minimum. Because optimizing things in code you do not know is extremely difficult. So everything that comes with performance implications, and for example MVC frameworks tend to do a lot of boilerplate around the requests, we need to keep those to a minimum that we know that it's not creating performance overhead. We've had a lot of projects where requests including network latency, the round trip can't be more than 150 milliseconds. And during that time we need to decide which ad to show which person, and the decision will cost us money. So they're getting that to work at, say, 20,000 requests per second requires you to know pretty much everything that happens in the code base. So we do not do full code reviews, but we do go through a lot of the code. Because if we're worried that it's creating performance issues, we should check it out before the worries actually cause problems. But all those obstacles we went through to get acquired by Unity. And now, at Unity, the product's Unity Ads now. Mobile video network runs in thousands and tens of thousands mobile games out there. And grown that way in about 2 or 3 years. So we did the hockey stick again on mobile. Large part being acquired by Unity, of course, helped us a lot. So now we're in the present. We should take a small break since it's been about 40 minutes. Alrighty. Question?
Yes, I'm
No.
wondering, because you must have done, since you were such early adopters, a lot of experimenting. Did you always write vanilla JavaScript, or did you use any comparative languages at any point?
On the server side? Nope. I was trying to think, but I don't think we did at that point.
Did you experiment or then decide not to because?
I think that at that point the options were limited. So, and we had very little time and resources. I mean, we had like, I think 2 or 3 backend developers at that point. We need to keep the big system running, and we need to pick new technology and build stuff around. So, luckily, stereotypical, I can hack on the weekend for things that might be interesting in the future work. And we got new technology, but it was very much a startup mentality. Oh, we're going to go with this. It worked. Doesn't always work like that. But we got lucky. And, I mean, we are still with it. So currently, we're still running Node.js on the back end. There's a lot of servers that we run. I think we have our max number of instances running at the same time is somewhere over 400, if I'm correct. On average, we're running, 200 some instances on AWS, and they're not the smallest kind. For databases, we still use MongoDB. It still works well. The thing it's good for is it stores more complex data that has structures, advertising campaigns, user profiles for our B2B customers like advertisers and game developers that we store information for. For data that is large volume, which in this case means tracking the end users we see in games, we migrated over to Cassandra about a year ago. Yes. And have been very happy with it because we were seeing the performance implications of using MongoDB for those. And Cassandra saved us a lot of time and money once we eventually got there. And of course, every now and then it breaks down as well, but everything does at that scale. And then we've adopted Redis, which mostly works as a cache for us to make sure that not every query has to hit MongoDB or Cassandra. On the front-end side, we've actually adapted mostly to AngularJS and a Bootstrap combination. A large part of that is for us to be a part of Unity Technologies these days, which is the toolset that Unity is now building its online services with. However, it's not a bad choice. Angular is good for getting shit done fast. So, now, Backbone is good because it is exactly only that, a backbone. You have to write everything around it yourself. It's good for those who would do it anyway. It's good for people who suffer from not invented here syndrome. So, on the infrastructure side, we run everything on AWS. I think we have right now 0 physical servers that we run ourselves. We used to have 1, then it broke down. It will be missed. We used it for IRC mostly. And we use Docker for deploying things. Because as said, yes.
So you're using Docker, or are you also using like ECS as an R?
No.
No.
What are you using? You wrote it.
Yes, I wrote my own because they weren't.
How good race you? I trust you.
It works really, really well. I have to hand it to Gara for our... One of the things that I really like saying that works well with us is our infrastructure and deployment. And I spoke to one of our developers this morning, preparing the last slides for this, just putting the final touches, not implying I did it this morning, but about our deployment, and he comes from a larger corporation, and what happens a while ago is he ran into his old coworker and talked about, hey, he's now working at Unity, it's cool, and tried to win him over, and that happened. The other guy joined us as well, and one of the things he said is like, our deployment works really, really well, and we control it ourselves. We don't have to go to DevOps. He's like, oh shit, really? It's magic. But I'll actually, yes?
Yeah, so how could you guys like treat this SEO stuff if you use Angular and Bootstrap at the front end stuff?
Sorry, how do we deal with what?
SEO, search engine optimization stuff.
We don't really have web properties that where we use Angular that need to be search engine optimized. Any marketing pages and pages on Unity3D.com are not built with Angular. They're actually Ruby on Rails. There's a separate web team in Copenhagen which you can address any questions regarding that too. I didn't say anything. So. But one of the things that we do things like Docker, and we do a lot of automation, and why things just have to work is that we grew a bit in 8 years just here in Helsinki. So when I started, I was employee number 8. Garo here was number 7, who started a week before me. I put 70 plus because I think we're probably 80 now, and we're growing. Blatant self-promo, we're looking for a lot more people. Yes?
Coming back to the infrastructure, do you use any message bus technologies such as, say, RabbitMQ or message queue technology?
Yes, we do.
Yes, we support Kafka and Rabbit.
Okay.
Yeah.
Into Kafka for like a high volume streams, and Rabbit for some like low volume but really like important messages.
And did you have any pain points with those? Have you always used those in the past, or did you change?
No, we've used different ones. I think it was called Q with a K, a message queue built on JavaScript.
Really bad stuff.
Yeah, do not use that. Do not use that. It's not. Comes back to not everybody should write JavaScript in Node, but RabbitMQ is good for actual transactional message passing that we need. And I mean, if you have the volumes, just go with Kafka. We protoed Kinesis from Amazon as well. There's a few we run into a few problems. Plus, it provides vendor lock-in. So Kafka is good.
Okay, basically, I did pick up Kafka because I know that we can handle 1 million messages per second, which is actually coming pretty soon.
Yes, that's not actually something like, hey, it can handle, like, we need to prepare for that. So we have a large set of events, and it's going to be a lot more, and we're building more robust Kafka infrastructure, so we're actually investing a lot into building on top of Kafka because it is a great solution. And compared to other choices we've made around technology, it's actually stable, and there's a lot of information and support available for it, which is refreshing. Okay, I should not have done that. Swipey thingies. Sorry about that. I'm not good with computers. So,
you need people to help you, man.
Yes, I need help. So, we've grown a lot, and of course, we run a very, very large business these days out of here. I mean, in Finnish scale, our business is enormous. Unfortunately, I can't share the numbers; they're not public. But it's very big, and of course we've grown a lot, so we have a lot of requirements for how we do things. So we try to aim for we do 99.9% uptime. Now the question is like, why are you not aiming for 100% uptime? And I have to agree with some smart people who say that if you should never aim for 100% uptime, because there's 0.1% downtime you use for putting in new shit. Because if you would aim for 100% uptime, the main job of DevOps would be to restrict change. And that's not a good thing. We are okay with having downtime as long as it makes sure that we have the adaptability to try new things. Put in new technology we're not 100% sure about. We must have continuous deployment because we do deploy multiple times a day to production. That is a must for us. And we must handle massive scale. And so, talk about that is how are we actually doing that? One of the big things is testing. We could not do all of this unless we were really, really strict on quality and testing. That doesn't mean that bugs don't go by. That doesn't mean that people don't write code that makes them go like, ooh, shit, that's ugly. At least it should have unit tests. That probably doesn't show up very well. But we do two types of testing. So we have to do API testing and naturally, of course, unit testing. I'm sorry, it's a bit small. But basically, API tests run through our good scenarios, trying to verify that everything works as expected by injecting test data into the databases, verifying that we get expected results, and everything runs the way expected. Then, of course, we have unit tests that we do to make sure that everything works as expected on the module level. On there, we have the usual suspects for, so Mocha for running the texts, which probably everybody uses. And should for basically assert. And sign-on, or Sinon, however you pronounce that in English, for mocking. And one of the big things that we believe is actually, especially with Node.js, is test-driven development. Because of how versatile and flexible and not type-safe the language is, by making sure that we do TDD, we actually get the tests done in the proper order, and we focus on making the right code for that. Especially on our Unity Ads network, where it's a very rather well-defined product. We know how it should behave. TDD is extremely important for us. We don't enforce it, but people actually gravitate towards it naturally. And with unit tests, we actually have almost 100% statement coverage. Now, of course, I mean, if you go and say, I have a 100% statement coverage on unit test, that actually doesn't mean shit yet. Combination of API test and unit test and making sure that the people know what they're doing when they write unit tests is actually the key to that. But the reason we really focus on tests is that to be able to do continuous deployment, we must aim for 100% test coverage. And I think Garo saw this firsthand when he tried to deploy a hotfix and couldn't get the tests pass. Yeah, so no hotfixing in unsafe matters because the tests will tell you nope. Computer says no. And I think one of the biggest reasons in Node.js for to do this is that the tests are actually our compiler safety type safety check. Because one of the big issues that we do notice in production, which will break things heavily, and for us running an ad network, we don't break things.
Are your continuous deployment, is it automated so that whenever...
Yes, next slide. I saw that coming. So, for us to be able to, with confidence, to do continuous deployment, we must know that we write proper tests to make sure that we don't break anything. Because running an ad network any downtime costs a lot of money. And we can't have that, because that would be annoying.
So do you review your test code?
We review all code. So all code going into master or development is done in a branch. All code goes to master through a pull request and a code review done by at least 2 people. And those reviewing it are also then responsible for deploying it. So if you get something to review, you must really review it because you are responsible for deploying it. So if you then saying, I've glanced through it, deploy it, it breaks, it's your fault. If you don't know what's going on, you get up from your chair, go to the guy saying, explain, why are you doing this? Given it's JavaScript, that happens a lot. You have this callback, this anonymous function that goes over here, and then I have no idea, why is this a rabbit? So the language has its ways of baffling the mind every now and then. So for us, that's an important. We haven't always done that. It has not gone so well. So growing, getting more people, because one of the reasons that we haven't done it is that we used to be a smaller organization where we had one guy doing one part of the system. Then it's like, hey, can you review my code? And everybody's like, I don't know what that does. I can't review it. So that was a problem. Add more people to the team, decrease boss factor, everybody's happier, things work better. Our systems work very well. I mean, we all know there's things we could do better, but of course at the end of the day, for us things run well. And one of the things is that we must have is automated deployment and things happening magically to the developers. Because they need to be able to handle the development themselves, and they need to be able to roll back in seconds if required. And we have the ability to do that. And since we are an ad network where things happen, traffic comes, traffic goes, we need to be able to add new instances on AWS in minutes. It used to take about 45 minutes before Docker. That was not very cool because then you start provisioning new servers when a peak comes in. All of the rest of the servers actually died before the new stuff came online. That was not handy. And then the new server goes online and it's like, oh shit, too much load. Let's start new servers. And before they come online, the traffic's down. Then we have way too many servers and they're like, what the fuck is going on? Then we downscale, takes a little time, more traffic. You see the problem. Now we have Docker. Everything works better. So how it works in this beautiful diagram, I was lazy, I didn't bother designers, I used Microsoft Clipart. I haven't done that in like 20 years. So we have a developer, makes a comment to GitHub, into master, which then notifies Jenkins through hooks, which notices, hey, yes, there is indeed a new version available that I should pull, clones it. So at this point, the Jenkins environment builds the new Docker container, and the system is built within that container, and all tests are executed within the container to emulate an actual environment. Should the tests pass and everything goes green, the Jenkins CI system pushes it to the Docker container to S3 and marks it in our private Docker registry available for deployment. So then the developer goes in, logs in to our terminal, just says stuff. I don't actually know the actual command, but instructs the system to deploy, which takes the container from the S3, and happiness ensues for the developer.
The time from like the commit to having the new version running in at least 150 servers is less than 5 minutes currently.
So if we break things, one of the big things is that we must be able to fix them immediately. So one is having rollbacks happen in the matter of seconds, and then pushing new versions if you can't roll back because even the version before was broken or shit is hitting the fan really, really badly. In 5 minutes we can get new versions up and running. And this is actually something that we noticed that we must do. But to really, really help us scale this is understanding the weaknesses of Node. Because we run at such scale that when we do new code, when we do changes, we need to know what to watch out for, and we need to know what's okay. For example, yes, leaking memory is easy, and debugging memory leaks is insanely difficult. Well, that's fine, as long as we do it in a smallish fashion and we can restore the servers. Sorry. But it is something that we know it happens. We need to be careful for it. Sorry, something is making me cough. Captain Obvious. Then callback hell. Anybody writing more complex JavaScript has probably known this. I mean, especially when we were a smaller team and something went wrong on a Friday evening, I happened to be on my computer. I had a habit of, okay, let's go into GitHub and start checking the code. What could be causing this? So I don't call out to the developer saying something's broken, but hey, this is broken, you could fix it right here. I start debugging. I was like, okay, it's here, then it's there, then it's there, then it goes, oh God. And the bigger the system got, and the system is rather big right now, the worse it got. We do a lot of database calls, we do a lot of I/O, and everything should be, of course, asynchronous, which means we're using a lot of callbacks, which makes it very, very, very annoying every now and then. But since we've known it for some time, it allows us to really make sure that we do development so that we do not create unnecessary callback hell. With Node.js, I don't think there's avoiding the callback hell because the language is one big fucking callback. But there are levels to it, and it's something you need to really know when you get into Node.js, that what are you getting into, because you will not find your way out of the rabbit hole once you go down that.
Have you been looking into the ES6 and generators for fixing the callback helping?
We are actually looking for like moving with Go.
I'll come back to that.
That's the actual question. We're using async await in our front end stuff now.
Yeah.
So for example, that helps a lot with, or generators for that matter, help a lot with the so-called callback help. And if you have the luxury of using those, then that's a good way to avoid it.
Yeah.
I use the using callback now, and do you think about switching to like promise?
Well, like in all of our, let's say, products that have been in production for, let's say, 2 years use promises, but like promise is a good halfway step between the actual async await stuff and then callbacks, because it's of course it makes stuff a lot simpler, it's easier to manage and so on, but still it's not the same as doing like synchronous stuff. But async await pattern, that's actually like it makes JavaScript once again like pleasure to work with.
Yeah, but I mean with promise you don't have to run into it.
It's not a pyramid of doom, but you still have callbacks all the time. Like it's not the pyramid of doom, but it's still a callback because you still have to like you're constantly adding new functions, and it's not making your code. It's still readable, but it's not as readable as it would be in a like.
I like the fact that one of our lead developers refers to this as the pyramid of doom.
It's a common term.
Yeah, I know, but still, the fact that you're using it, you know. And then, of course, when it comes to performance, this is the biggest issue. And this is probably one of the biggest things also that is making us move away from Node. How many of you are facing issues with Node being single-threaded? A few. Right, so you're going to get bored, because I'm going to talk about that for a while. So, this is not really a problem for small-scale stuff. Scale in Finland probably still doable. I mean, we're still doing it, but we are feeling the pain of it. We're having issues with Node being single-threaded, and we have to find ways around it. So, single-threaded stuff, how it works. Basically, what we have here is on the left, we have a request coming in. The red stuff here indicates active CPU being used by Node. The green is sync processing, database calls, things like that, then response is coming back. So what we have in your normal case, your request comes in, you do some processing, check out the headers, check out the request URL, start building, going through Express, and then hits your first database call saying, hey, look up this user, who is this? You start waiting, you get a response, you do process again, shoot some new database queries to get some more information, come back, process, respond. Next comes in a bit later. So then you have to wait a while to get CPU time in the same process, do a query, get a response, it takes a bit longer, process it, do a few more database queries, come back, do a response. Then you get the next request. Now what happens is that you're blocked in that process for some time. It takes a while for you to get active CPU time for that request. You do again some database response, you get a query, you get a response, come back, have to wait again for a while to get processing time for that, do a few database requests, again, come back, respond. Now, it's manageable. You get around it, there's some lag. Now, then there's the thing that, for example, if this is a query that we ask for some user properties, where, for example, the average user has 1 to 5 properties. What if there's a thing, one of them has 1,000? And the processing starts taking a lot longer, and this is a very much normal scenario for us. There are some users that have a lot more data than the others. So this happens. We get a big response from one of them, and the processing of it takes a whole long time. And it pushes back everything after that. Now, suddenly we come into the situation that maybe 1% of the requests start taking really, really long. And that's really, really hard to point out. You miss that for a long time. You don't see that until you start figuring out. You get more small error rates, and like, well, okay, if it's 0.1%, it's not. Yeah, I can live with that. However, it does have an impact on everything. Even though most requests are getting it back very quickly, there's a lot of stuff being pushed back. Requests are taking longer and longer. You have more and more open connections all the time. So there needs to be ways to work around this, to mitigate this. So, for example, when we do, of course, natural is you're going to have a lot of processes that Node runs on. For example, we have 8 CPU machines which all run 8 Node processes. So, of course, they're going to be distributed between them, but of course, a lot of these processes are going to be hit with a lot of connections all the time. So, what do we do about this? And making sure that our requests don't take a whole of a lot longer time than they should be. So, there's not very much that you can do. It's something that you have to live with because Node is single-threaded. So, of course, if you are writing code that you know that sometimes you could be iterating with large amounts of data and takes long, so you could write code that kind of splits it up to multiple processing ticks. So, yield over every now and then. Well, that means that you're going to have a shitload of complexity in your code, in your for loop, that actually iterates it differently. Then you're again in callback hell, you're going to have a lot of things that can break. This is something that we have to deal with, and this actually annoys us. And measuring and monitoring these spikes is a nightmare. We actually had a long discussion about this a while ago on how do you point this out, and one of the people working here who worked at another company, which is one of those companies in Finland that has volume, said for them it was basically, well, we stare at the load balancers like crazy and see if we see something odd. Do stats and things like that. But there is actually a trick that you could do around this, which is basically so that when you do the requests, what you do is you do, using set timeout, do code that gets called, for example, by default in 100 millisecond intervals. Now, since this is a single-threaded model, what happens is that if you then have some other database processing or something like that taking so much time, it will mean that your next set timeout will be delayed. And you can measure that, and if these start taking too much time, there's too much of them, you raise alerts. These are workarounds, and we need to look at to try and figure out what the hell is wrong here. Another thing that is causing us a lot of extra work is that since they're single-threaded, it means that you cannot cache data efficiently on the local machine, because all of the processes have their own memory spaces. So, we run 40 Redis instances to act as data caches. And we still have to run memcache on top of that to make sure that everything works. How fun is that? And while Node does give us a lot of tools, there are a lot of limitations that we hit because we deal in such large volumes. And it's actually causing a lot of work for us to get around these. Our DevOps have to set up servers, we have to really optimize things. And like our DevOps pointed out to me, which I actually didn't know, is that if we have, for example, on average 200 servers, and each of them runs with 8 node processes, so that's 1600 node processes. If each of them would want to cache some data in that process memory from the database, if we restart, that would mean doing the caching of data 1600 times, which usually consists of getting those complex queries from the database. That takes a little longer, which means restarting the production servers will degrade our performance a lot. And that's just because we have to do it like this with Node. So there are actually issues that we are hitting with Node which are bad enough that we're actually thinking of alternatives. And one of the issues is also that writing CPU optimized with code is actually extremely difficult because of how it's built. And since it uses JIT, which is not very well documented on how it optimizes its internal performance, and the language is dynamically typed, it makes it very, very difficult for you to predict how the performance will work. Because JIT will, or eventually if you do certain things long enough, start to optimize it, then in JavaScript you could actually accidentally change the type of one of those things it's optimized for, and everything breaks again. And how do you debug that? You don't. That's the fun part. You just live with it, and then you drink more alcohol. Until you forget.
What's wrong with that?
It's gotten us here. I'm worried about some of the guys, but...
Have you considered like something, well, there was already a question about like dynamic languages and like meta language on top of like Node on JavaScript. So have you considered like things like TypeScript or something that would like alleviate this problem?
It would make the debugging even more complex.
Yeah.
Any layer
it's adding layers on top of that, because
the production still runs the actual stuff. Okay, then how about like going hardcore? Like, have you like how often do you like disassemble the code?
With Node.js, it's really difficult because there's no really.
It's actually not that difficult, but as Tuomas said, as the JIT basically might make the code that if you disassemble the current, for example, current code path that you're running then, and then you, for some reason, as we're using MongoDB or anything like that, integer variable is suddenly a string. It basically invalidates the inline cache of V8, which means that all the disassembling that you've done is basically for nothing, because the actual code that you're running in production, sometimes it might be one request out of 10,000, which is basically invalidating all of the caches, and then you're back where you started.
So what I tell people, which is not possibly always the best thing in business to do, is like there are certain issues that you can fix by throwing money at the problem. This is one of them. Adding more servers in AWS is sometimes easier and, funny enough, cheaper than trying to optimize everything. Hardware is surprisingly cheap. Focusing on what you should be actually doing is making your product better rather than trying to fix some stupid CPU optimization or memory leaks in the language. Like, you should not be doing that. You need to focus on why do you build a product, why do you make more money, why it's a better business, and not fixing shit like this. That's what it comes down to.
So maybe I'm imagining this, but I thought StrongLoop had some sort of analysis tool to try and detect that long event loop turn. I don't know if I imagined that, but is there some tool to try and spot when the event loop is taking too long?
I think there's a lot of tools. And there are a lot of things you can do. What it comes down to is how much money you have to invest in doing things and how efficient that is. Because, I mean, we know there's event loops that are taking way too long, and we know the reasons for it. But what we can't fix is how it affects things around it. Because if we get a database response that has 10,000 rows and we have to process it, it's really hard to try and optimize that. Because we do need to process it. And we know it's happening. That the problem is that we really can't fix it. But we have to go around it, which costs us money and effort and beer. Not always in that order. But all that comes down to is that we got far with Node.js, but looking into the future, because I've also babbled on for almost 1.5 hours, so I think I need to wrap up before all of you die or something. Would we choose Node again? If we were right here in 2015 with all the choices available, would we do it again with Node.js? And the answer is probably not. For all the reasons listed there. We got there, knowing all of that we did, we know that Node.js is useful for prototyping. We can build things quickly. That is what it's good for. I mean, it's easy to get started. It does create a very heavy burden on sustainable development environments. We're seeing it in DevOps. We're seeing it in our engineering practices. We're seeing it in the amount of unit tests and integration tests that we have to write for code to make sure it works, which is caused by how the language works and the constraints we know. So it requires a lot of discipline from the development team to make sure that it actually happens and nothing bad happens. We need people who know what they're really, really doing because they don't want to hit the constraints. In the end, it's the right tool for the right task, but building these kind of systems, we believe it is no longer the correct task. And for us, we don't have 100% clarity on what is the right tool, but right now our money is on Go, which fixes a lot of the problems that we have seen. But only time will tell how well the future do with Go. So maybe we'll be here in 5 years and I can tell the same story in Go, but you never know. Yes?
Yeah, so how would you compare like Go and Java? Because like on the other hand, like okay, there's like some another language that has, let's say like 10 times the kind of how to say 10 times of the like lifespan of Go.
Yeah. So Jaakko, do you want to compare Go to Java?
What?
Go to Java. Pros and cons.
Is there a comparison? Well, Go for starters, it's a lot more straightforward and simplified. Like if you compare to Java, you have a lot of overhead of like building classes and actually trying to, well, classes. That's probably the key word in this one. But it's basically I think like it's a more manageable C. So people who prefer C or C-based, like C, yeah, well you could say C-based language. Even if it's Java, like Go is a good option. Even if you're doing JavaScript, you will learn Go in about like 4 days. So.
It's a Node.js meetup.
It's a Node.js meetup. I don't want to bash Node.js. Like, we use it a lot. It's taken us where we are now.
Yeah. But on the other hand, you know, you're trying to scale up. You know that the 1,000 times more Java developers out there.
Yeah, but Java developers, this is what was actually one of the questions that came up in one of the Go conferences, and one of the people from the audience asked, like, what?
I think you need to probably take that.
Okay, let's get back to that.
Yes, he unfortunately has a life.
Sorry, I can continue now. So one of the people from the audience asked, like, where can I get Go developers? Go is a brand new language. Where can I find them? And the speakers say how to Go developer. Like, take any Java developer or a JavaScript developer, basically show them where 1 week later syntax or the actual paradigm. It's like it's just a simple language.
I seem to be the exception to that rule, though.
Are you sure you're not going to run into the same issue? Like there's going to be a lot of developers who should not be developing.
It might be in the future, but currently the community is based on. I'm not saying that nobody else can code, but the academic people. Still, most of the community is based on people that are there to actually solve really, really hard problems. So the quality of the libraries that you get are usually from people that either work for Google or Facebook or are from some university actually designing new algorithms to figure out stuff that we would otherwise have to solve by ourselves. So
but probably is the same reason why 5 years ago Node was good, because it was only coming from Google and not
No, and I think one of the
And actually, for Node.js in the beginning, it was like that. It's basically the people that use Node.js use it for the same reasons that we did.
Yeah.
And it's not that it's gotten of course, like Tuomas said about NPM, it's there is a lot of, you could say, clutter, but of course there's
good stuff.
Really big and smart, really big companies, smart people doing a lot of really good quality libraries that we can actually use.
I think one of the advantages Node has had in building its community is that the language used was well known to some web developers already. Go has that as a disadvantage and an advantage. A disadvantage, there's more ramp-up. Advantage, then you don't have the jQuery people writing packages. I'm not trying to bash him, but it's a very different world. Yes?
Yeah, would be interesting to hear what other options you have considered to go as the next step, and how would you assess those?
So one of the things that does come around every now and then, which I don't see as a option we should push off the table, is Java.
Why Java?
That's a long discussion.
That's the question that everybody is thinking.
Now the thing is that if we look at product development where we are right now, is that we are in a stable product phase. We must maintain an existing product performance and build on top of that in a very known space where we have to do less prototyping and more building directly for scale. And we do, since we're an ad network, money changes hands. We need certain level of trust in the environments. Java, also, I used to be a Java developer, so I'm partial to that. But I like the language structure, and I mean there's a lot of developers out there, so there's a lot of tools for that. Yes, there is overhead, but performance-wise, it is actually rather good as well. It's not as bad as it used to be, but I would say Go is winning. Java's a kind of like a potential dark horse. Node, for a lot of new things that we're building, is potentially off the table. Not completely. We will need a lot of Node in the future. These things will not go away in a while that we have, and some things we will want to build in Node because they need to interact with existing systems better. With new systems that we're building, there's going to be tough decisions for us. We are building one new product in Go already, which is far along, but it's not probably the correct choice for all. However, we need to maintain so that our technology stack doesn't contain a bazillion different languages, because that's just not maintainable.
Yeah, but if you're looking at Java, for example, you said that the environment is stable.
Yeah.
But I mean, why not considering some other languages based on the JVM? So like Scala or...
Yeah, I kind of count that under Java. So it's...
Okay.
Yeah, it's not the same. Scala is not the same thing, but Scala is an option, but we also have people here who've been bitten in the ass by Scala. By having not so great experiences and running into issues there. Like JVM variants are, of course, a possibility. Scala cuts down a bit on the developers, but there's quite a bit of them. And Scala, on data processing side, we are using Scala for some things, like this building stuff on top of Kafka, Spark, building on Spark and stuff like that naturally gravitates towards using Scala. But building a large-scale ad delivery, I don't know. There's a lot of decisions we still need to do. There's one here first.
Yeah, well, I understood that you are not going to start any new Node.js projects.
Not quite true. We might.
Okay.
And there's things we need to do around existing projects. Yes, but go ahead.
I understand that like the really high throughput APIs that possibly handle big objects might be a bit of a pain to handle with Node.js. But on the other hand, I would like to hear some of your thoughts on why Node.js has made you faster in prototyping and developing when compared to other choices and these new choices that you have made. How do you feel like they are actually slower to develop? And why?
You know, I think one of the things that I personally see as a nice thing in JavaScript, because it is not a statically typed language, allows you, and the structure allows you to refactor things maybe faster. You're not so set in stone as with Java when you start creating abstractions for your project. If you want to refactor everything, you're going to be hands deep in changing pretty much everything. And with JavaScript, it's maybe easier to and faster to create stuff without really thinking too much about the structure. Well, no, okay, this is personal preference. Some people might disagree, but and there's very little overhead in building with JavaScript. Just grabbing something like Express and Node.js will get you up and running very fast. So simple things can be done very quickly. And I mean, that's the point of prototyping and putting stuff up and seeing. Now, of course, these often go into production, and Jaakko wants to disagree with me on everything.
Yeah. Actually, even though we are moving to, especially on one of our products, we're moving a lot towards Go. We still have huge like parts of the products that actually use Node.js, but they are only parts of the product that don't do any processing. They only do I/O. So, for example, we are using GraphQL, which is, I don't know, some of you might know it. It came out like 6 months ago, so it's
Speaking of bleeding tech again.
But still, it's for example, it's Facebook released the JavaScript version or / Node.js version of the GraphQL endpoint now, and we are basically happy with that, because then with that we don't actually do that much CPU intensive stuff. We're actually relaying connections to all of our Go servers, and for example, for that sort of solutions, it might be even the optimum solution, because we can develop it really rapidly. It's easy to change, easy to refactor, and of course the actual tooling and community support for GraphQL and that sort of stuff is currently only for JavaScript. So it's like for some solutions, it's like you have to pick the platform and language based on the problem that you're solving. If you're solving something that's really CPU intensive, like don't go with JavaScript. If you're solving something that's almost only I/O, then like why not go with Node.js, because you won't probably run into the problems that you would otherwise face with Node.js.
Actually, I have a question for you and your experience. So now you're in 2015, but think about going back, not in time, but in size. So now you have a company that is not 8 people anymore, but it's 4 people. Mm-hmm. So what would you do? Because you can't do everything with 4 people, and you have this wonderful company you want to grow. And So this is maybe closer to us. I mean, we are still, mostly startup and something like that. So what is the difference that you would do now in 2015? Not in. So which one of the lesson you learn it's the must that you can do it for people, not with 70 or 80 or much?
Depending on what you want to do. I mean, yeah, if we'd want to build the same thing, if Go were available, we would probably, to some extent, go with that at this point, because it provides a lot of the benefit, and scaling up, like actual scale, more requests per second, would be more easily handled by that stack. Then probably would put more effort into database stuff and go with Cassandra from the get-go, but only to an extent, because what we understand, I mean, Cassandra is great for well-defined high-volume operations, but since it is not quite the same as SQL databases, but it does have a schema, it is not as flexible as MongoDB. As long as you keep prototyping or extending and building your product, MongoDB is faster on that, because it is easier to change that.
Of course, with Cassandra, you will run into problems with the indexing, because like with MongoDB, you can actually, like if you have the data in the specific collection and you add an index, you can actually query that, but with Cassandra, you actually have to design your tables and your data structure based on the fact that you basically have one column, which is the index for all of your data. So you suddenly have to start denormalizing all of the stuff. And if you need, like,
for us, our application, it works, but it doesn't work for everybody. So MongoDB is still a great choice. I personally like it. It's very versatile, and it does scale up to a point. So I mean, Go plus MongoDB would be probably an excellent starting point. But depends on the application and what and how I/O intensive. But for us, I would probably, if I would do it again, I would get better meds this time. But barring that, probably Go.
Yeah, and actually I think one of the key lessons is not actually about like what language you choose, but what architecture you choose to build your application on top of.
Yeah.
Like we nowadays, like we have a lot of a lot better infrastructure in terms of like how we do DevOps and that sort of stuff. So what we are now able to do is that we are able to deploy a microservice infrastructure much more easily. So we don't actually have to make a set like this and that, like, oh, everything will be in Node.js or everything will be in Go. We can like choose to do some portions in Node.js, which are something that we have to develop it rapidly or change a lot. But for example, if we would do the ads delivery now, I think the high throughput stuff would be in Go, but of course the admin side and the backend for the admin side would probably still be Node.js.
Yeah, I think that nails it, because I think one of the things is that we would probably be more modular even when it comes to technology. So I want right tool for the right task, and we would probably not just pick one.
Yeah, it seems to be that now Node.js is for productivity and Go is for performance.
Yeah.
And you have to start it based on that. It's like with every like language or tooling that you can choose. So like same with database. Like if you want to be rapid in your development and you don't have a really high throughput or heavy load, MongoDB might be the best option that you can get. It's actually like going with Cassandra. You might spend like multiple man-months in actually trying to figure out your data model to fit into Cassandra rather than into MongoDB. And if you have that like a couple of months to spare, then it's probably fine.
Yeah.
But like, who has 2 extra man-months to spare just to like design data structures for something that in MongoDB could be one collection where you just insert stuff and add a couple of indexes and that's it.
Going back about Node and Go, because I have no experience in Go. But one of the things you are saying is that with Nodes it's easier to talk to the front-end part of the company and so on. Isn't Go the same or?
It's basically the same. Like Go is designed as Go is designed by Google. It's a like web company. It's built to read and eat JSON. And that's basically what you need to actually communicate properly with the front end. Of course, you're not able to share the code, but I don't know how many people actually.
In practice, you don't even do that with Node.js anyway.
People are always saying that, oh, it's great to use Node.js because you can share code with your front end and back end.
That doesn't happen.
Who is actually doing that? Oh, you are really. You pray dudes. Like, hopefully you don't have a settings JSON with all of your API secrets or what you actually include to your front end.
So.
Yeah, like one thing that I'm like personally worried about Go is that okay, basically it's developed by a single company, of course like used by multiple different companies. Really like like Google is like using it like internally.
Yeah.
Who guarantees that Google is like interested in fixing like anybody else's problems on Go?
They're kind of like Java.
It's a Java program.
Yeah, but it's already open source, and it used to be a couple of years ago. If you asked the same question, I would have been like, hell no! Like we didn't even use Go here because of that reason. It wasn't a it wasn't a mainstream language. Sorry, or white wine.
Yeah. Over here.
Yeah, he gets to drink one, I don't know.
But still, like but nowadays it's actually the community is really huge. Like a lot of big companies are actually contributing to the actual language and the compiler instead of just using that. So in the end, for example, it's the same with Node.js. If Join disappears from the world, it doesn't mean anything for Node.js. If Google disappears, of course, it's a big contributor.
There's going to be a lot of other problems at that point.
Yeah, we have bigger problems then. Google decides to drop support for
and nobody cares. Nobody cares.
Like, to be honest, like to some extent, you are a competitor for Google in terms of ads.
Yeah.
And I don't actually know how this kind of what are the like rules
Google
for like
doesn't have any, for example, a patent agreement that you actually sign up for when using that.
Yeah, sure, but how does it go upstream contribution? Like if you like face some like really hard problem, will that mean then if like Google doesn't like want to work with you guys, will you go with your like own like fork of Go?
Hopefully not. That sounds terrible.
In 5 years, yes.
It sounds like we're doing something wrong if we want to go with our fork instead of.
No, I think I'd like to do something like really like right if like Google wants to fight you.
Yeah.
Well, that will most likely end badly, though. They have more money.
Well, then we probably have the luxury of being that big and that important that we can make our own Ulang. It's a fork of Golang, but it's Ulang. And that's a promise.
I know there was a really successful car some years ago called the Yugo. Very
All right.
popular in Poland.
So, I'm done. So, thank you all for coming, but one last thing. We are hiring. You get to work with a lot of fun problems like dealing with single-threaded node. or learn Go, either way.
It only takes 2 weeks.
Yes, but shut up for a second, sorry. So we do build a lot of things on Node, and that's not going away in a while, so we are always looking for brilliant people to join the team, and we're fun to work with. Those guys at least. I'm not. But I hope you enjoyed. Unity3d.com/Helsinki will tell us the story of our office here, what we do, what we provide, and what are the open positions here. And you can also come poke me. I'm not leaving directly or anything like that. So I hope you stay, drink a few beers with us, come chat with us, tell me why I'm wrong, and have a fun evening. But thank you.
All right, give us.